Okay, so we're given the question, find a polynomial equation for the table of values. So basically we got to find an equation or a function of x that corresponds to these x coordinates and y coordinates, and we can do what we learned with finite differences like we did in the last video of this playlist. So we're going to do the finite differences, the first ones. So you're going to do 540 minus 210, and that's 330. So we're going to write 330. Then we're going to take 210 minus 48, which is going to be 162. 48 minus 0 is clearly just 48. And then 0, subtract 12 would be negative 12. And 12 minus 30 would be equal to negative 18. So clearly none of these are constant, they're all different. So we're going to do second differences now, and 330 minus 162 would be 168. Then 162 minus 48, that would be 114. 114. 48 minus negative 12, so it's going to be plus 12, which would be equal to 60. And then we've got negative 12 minus 18. So it's going to be negative 12 plus 18, which is 6. And once again, these are all different. They're not the constant value, so we got to go to one more. So 168 minus 114, it's going to be 54. 114 minus 60 is 54, and 60 minus 6 is also 54. So we can now say that the constant value is going to be, or not 3, it's going to be 54, not 3. 54. But the degree, since it's the third difference, that will be equal to 3. So now we can find the value of a to see if it's stretched or compressed, or if there's any transformations at all. And we can do that with what we learned, v equals n, a n factorial. So then sub in what we've got, 54 equals a 3 factorial, and we know that 3 factorial is 6, so then we can do a is equal to 54 divided by 6, 54 over 6, and 6 times 9 is 54, so we know that 54 divided by 6 must be 9. So that's what we got so far. So you could write this two ways. So we can see a root is when y is equal to 0, because then it will be crossing the x-intercept, and we can see that right there. So we have one of the roots. So it would make most sense that we would start working with an equation in factored form, because that's what gives us our roots. If we didn't have any roots and there were no zeros in the y values at all, then it would probably be smarter to use standard form. And standard form can be written like this: y or f of x is equal to ax cubed plus bx squared plus cx plus d. But since we do have a root, we're gonna prefer to write it like y equals a x minus s, x minus q, x minus whatever variable that you want to use. So these are just ones that I choose. And since we have one of the roots, which is 0, 0, 1, in the table of values to our left, we know that x is equal to 1. So in factored form, it would be y equals, and then we can sub in our value of a as 9. And then if x is equal to 1, then if we equal that to 0, it would be x minus 1. That's what the root would look like in factored form. So then we got x minus q, and then we've got x minus t. Okay. So that's what we got. That is what we have so far. Now, what are some things that we can do to continue this, and how can we basically, if we have two unknown variables, we've got y, or we've got q and t, because we can sub in different y and x values. So we need to come up with two different equations that we can use either substitution or elimination for to find out what the values of q and t are, to find what the other roots are, and to create our equation. So we're going to start off with the simplest point that you can find, because why would you use 0.4 comma 540? That's such a large number and it's so hard to work with. So I like we've already used the root x and y, so the next point that I like is 0 and 12. And the reason that I like this one a lot is because we've got a 0 as our x value, so it's going to be really easy to simplify. So equation 1, we're going to sub in the point 0 comma 12. So our y value is going to be 12, so 12 will be equal to 9 times, and then 0 minus 1, 0 minus q, times 0 minus t. So then we know that 12 will be equal to, what's 9 times negative 1? That's just negative 9. And 0 minus q, that's just going to be minus q. And then if we got 0 minus t, it's just going to be minus t. So now if we wanted to, we could divide out negative 9 from both sides, and we could get negative 4 over 3. Because 12 divided by negative 9 is simplified to that. And then what's negative times a negative? Negative times negative is positive, so that means that negative q times negative t is really just q times t. So now, this is one of the equations, but I prefer to use substitution because I'm more comfortable with that. So we're going to use substitution in this video, but you could very well do this with elimination if you wanted to. But so we have to isolate for one of the variables, either q or t, and let's just say that we'll isolate for t in this video. You could isolate for either one. So we divide t by both sides. So, and let me just change the color real quickly, because this may seem confusing. How can I divide negative 4 over 3 by t? But really, when you think about it, negative 4 over 3 divided by t, which has a denominator of 1, that's just going to be equal to negative 4 over 3 times, and then you flip the second one, so it's 1 over t. So that would be simplified to negative 4 over 3t. So then finally, we have isolated for one of our variables, subbing in one of the points. So we know that negative 4 over 3t is equal to t. Is equal to q. So we've got one variable isolated so far, but we only have one equation because we only subbed in one point. So what the next best thing to do is to sub in another point. So the next point that we can use, you can really use any of them. Some of you may choose negative 130. Some of you may choose 248. I don't want to work with a negative number because that might make it a little bit more confusing for me. So I prefer to use 248, but really it doesn't matter. You'll get the same answer if you do it correctly. So let me just draw a line, divide this a little bit better. So the next point that we're going to use is negative 248. 0.248. Okay, so we're going to sub that in to this one right here. Okay, so we got y, which is 48 in this one. 48 will be equal to 9, because that's our a value for the entire function. And then x is 2 minus 1. And then 2 minus q. Actually, that looks a bit like a z. Make sure that's a 2. And then 2 minus t. There we are. So then we've got 48, 2 minus 1, that's just going to be 1. 9 times 1 is 9, so then we could divide out a 9 from here, equals 2 minus q times 2 minus t. I'm just carrying that down from up here. So then 48 divided by 9, you could reduce that fraction to 16 divided by 3, because both of them are divisible by 3. So 16 thirds equals, and then for this, you could do it two different ways. The way that makes most sense to me is to distribute both of those out right now, so you could FOIL them. But if you also wanted to, you could just go straight away and substitute in your q value right now. But for me, I'm just gonna FOIL it out first, and then I'm gonna substitute my q value. But again, you could really do either or. It doesn't matter. So we're gonna do 2 times 2, or 2 times 2 is 4. Let me back that up. 2 times 2 is 4. 2 times negative t is minus 2t. And then we've got negative q times 2. That's going to be minus 2q. And then we've got negative q times negative t, which is going to be positive qt plus q times t. Okay, so now we have our second equation, and the best thing that we can do right now is plug in our value of q from the other point that we got, because that's our other equation. It's really just, it looks like a complicated version of substitution and elimination, because that's really all that we're doing. So let me plug this in the same color, or let me carry this out first. So we've got 16 divided by 3 equals 4 minus 2t minus 2 times negative 4. Oh, and let me just change the color for that really quickly. Make it a bit more clear of what we're doing here. And that's negative 4 divided by 3t bracket plus t times, and then the same thing, we got negative 4 over 3t. So now we have this, and we can definitely expand the multiplication of the things that we just substituted in. So we're going to do 16 over 3 is equal to 4 minus 2t. So the negative 2 times negative 4 is going to be 8 over 3t. So plus 8 over 3t. And then, okay, so here, if you expand it out, it's going to be negative 4t divided by 3t. But really what just makes more sense to me is that you could just divide out a t from this entire thing, so it would just be minus 4 over 3. So now we've got this big old equation. It looks kind of complicated. I don't really know what to do next, but I noticed that we've got 3 just numerical values that could really just be simplified into 1. So that's what I'm going to do to simplify this, to make it a lot easier to work with. So we got plus 4 on this side, so minus 4, so 16 over 3 minus 4. And then we got negative 4 thirds, so we're going to add 4 thirds to both sides of the equation, plus 4 over 3. And all of that's going to be equal to negative 2t plus 8 over 3t. So now we can simplify 16 over 3 minus 4 plus 4 over 3. So if we do all of that, then that will eventually be equal to, and I'm just going to divide this out a bit better here. That will be equal to 8 over 3 if you type that into a calculator. So we got 8 thirds, and that's going to be equal to 8 over 3t, and then we got minus 2t minus 2t. And we know that 2t is over 1. Over 1. So now what we want to do is we want to have all of these as a common denominator. So we're going to multiply each of these by 3t. So we're going to do times 3t to the top of that. We're going to do times 3t to the top of that. And we're going to do times 3t to this one as well. So we know these ones will cancel out. We can do this times this. Let me change the color, making it a bit messy. Okay, so 8 times 4, 24t, because it's 3t. So we got 24t over 3 equals, and then it's just 8, and then minus 2t times 3t is going to be negative 6t squared. Negative 6t squared. So 24 divided by 3 is just 8. So that's 8t. 8t, and then if we're gonna want to make this equal to 0. So actually, let me start by making this equal to 0. We're gonna make the right side equal to 0. So we're gonna add positive 6t squared to both sides, and that's gonna be 6t squared to the right side, or to the left side, sorry. Then it's gonna be plus 24 divided by 3 is 8, so it's 8t. And then we've got a positive 8 on the right side, so subtract 8 from both sides. So now we have a quadratic. We've got 6t squared plus 8t minus 8. And actually we can simplify this a bit more to make this easier for us. We're going to divide each of these by 2. So divide this entire thing by 2, you'll get 3t squared plus 4t minus 4. So now we have a quadratic that we're able to factor. So something that's going to add to 4 and it's going to multiply to 3 times negative 4 is negative 12. We got 1 and 12, 2 and 6, 3 and 4, and it's going to add to positive 4. So, negative 2 and positive 6, that's actually going to work. So we could now do 0 will be equal to, we got 3t squared, and then we got plus 6t minus 2t minus 4. So we can do 0 equals, we can factor out a 3t from the first side, because we're grouping now, and then we'll do t plus 2, and then we can factor out a negative 2 from this side, and then we'll get t plus 2 as well. So then we got 0 equals 3t minus 2, and we've got t plus 2. So now we've got two other roots, because t is really just x. This is just in factored form. We chose the variable t, but really these are just our roots. So now finally that we've finished, we've got our two other roots. We've got this root right here that if you equal that to 0, that will be a root. So that will actually be, that'll be 2/3 is one of our roots. And then the other one will be negative 2. And we've already got our first root because we've got it in here. And we know that since it's a third degree function, it can only have up to 3 roots. So we've found all the roots. So therefore, if we were going to write this as an entire polynomial equation, then we could write it as f at x will be equal to 9, which is our a value, and then we've got x minus 1, our first root, 3x minus 2, and we've got x plus 2. So, therefore, we can conclude that this will be the equation for that table set of values.